Hi there everyone. In this video, I will be discussing about rational expressions. By definition, rational expressions are numbers or expressions in the form a over b such that b should not be equal to 0. Now a is usually called our numerator. That's the number on top, and b is usually called or is called our denominator. Now I've mentioned that b cannot be equal to 0. Why? Because if b will be equal to 0, that will give us an undefined number. But a can be 0. The numerator can be 0. Why? If a or the numerator is 0, that will give us 0. So that's fine. The only restriction is that b or the denominator cannot be equal to 0. Now let me give some examples of rational numbers. So we have 6 over x minus 1. That is an example of a rational number. We also have z squared minus 1 over z squared plus 5. That's a rational number or a rational expression. So any expression or any number in the form a over b that has a numerator and a denominator, and whose numerator and denominators are polynomials, so that's a rational expression. Now for your attendance and for your participation, in the comment box below, kindly comment your name, your course, and your block number, and also give me an example of a rational expression. Now lastly, the expression 4x squared plus 6x minus 10 over 1. This is also an example of a rational expression. Now we're used to seeing this expression only, but regardless, for any number we can always put 1 as its denominator. Okay, so those are examples of rational expressions. Now let's proceed with reducing rational expressions to its lowest term. Now in reducing rational expressions into its lowest term or its lowest form, we need to look for common factors. We need to simplify those certain expressions so that in the end it will be in the simplest form. Therefore there will be no more factors, or in the end the only remaining factor is the number itself and 1. So for example, if we have 12 over 8, so this is an example of a rational expression. Now how do we simplify? So in simplifying, we need to look for the GCF, or the greatest common factor. It's a certain number, the greatest number that can divide both the numerator and the denominator. In this case, our GCF is 4. Now since it's 4, we need to divide the whole expression by 4. So divide 12 by 4, divide also 8 by 4. So whatever number you divide the numerator, you also divide it to your denominator. Now simplifying, 12 divided by 4, that will give us 3. 8 divided by 4, that will give us 2. Therefore 3 halves, or 3 over 2, is the lowest term or the simplified form of the expression or the fraction 12 over 8. Now we can say that this is in the simplified form. Why? the only factor or the only factors of 3 halves is the number itself and 1. There is no other number that we can divide the expression or the number with. Okay? Now, let's try this one. If we are given the expression x, say plus 3 times the quantity of x minus 1 over x times x plus 3. Now, how do we simplify this certain expression? Now, in simplifying or reducing to its lowest term, check the numerator and the denominator. Look for similar terms wherein or in which we can cancel. Now, in the numerator, we have the quantity of x plus 3 that's also present in the denominator. Therefore, we can cancel those quantities and we would be left with x minus 1 over x. Now, common mistake is some students tend to cancel x and x in the numerator and the denominator. We do not do that. Why? X minus 1 and x, those are different numbers or those are different quantities. So therefore, you're not allowed to cancel those numbers, okay? Hence, this is already the lowest term or the simplified form of this given equation. Okay? Next, let's have this one. The quantity of, or no, let's have x squared minus 2x minus 8 over x squared minus 9x plus 20. Now, how do we simplify or reduce this one into its lowest term? Again, you do not cancel x squared and x squared from the denominator and the numerator. You cannot cancel that one since those are different terms. Those are different numbers. And as a rule of thumb, if numbers are separated by the minus and the plus signs, you cannot cancel those. Okay, so what we need to do is we need to factor. So this is basically an application of our previous topic on factoring polynomials. Now, for x squared minus 2x minus 8, you can factor the trinomial into two quantities. So I've taught you before that in order to factor this certain expression, so first look for factors of the first term. So that's basically x and x. Now for the second terms, look for factors of negative 8 that if you add will give you negative 2. So we know that the factors of 8 that can possibly give us negative 2 are 4 and 2. Now for the sign, we need to have a product that will result to negative 8 and a sum that will result to negative 2. Therefore, here in the given example, 4 should be negative, 2 should be positive. Why? Negative 4 times positive 2 is negative 8, right? And using the FOIL method, if we check that one, that will give us positive 2x minus 4x that will result to negative 2x. Okay? Now for the denominator, we do the same thing. So factoring, factors of x squared, that's x and x. Factors of 20, that will have a sum of 9. So that's 5 and 4. Now we need the product to be positive 20 and the sum to be negative 9. So we can have both numbers to be negative. Why? Negative 5 and negative 4, that's positive 20. And using the FOIL method, if we look for the outer and the inner terms, for the outer, that's negative 4x, inner, that's negative 5x. So that will result to negative 9x. Now simplifying, we can cancel x minus 4 in the numerator, also x minus 4 in the denominator. That will give us the final answer of x plus 2 over x minus 5. Again, you're not allowed to cancel x and x from the numerator and the denominator, since those are different numbers. And again, if numbers are separated by plus and minus signs, you're not allowed to cancel. Okay, so therefore, this is our final answer. Another example, suppose we have x squared minus 25 over 5x minus x squared. Now I think this is very familiar, since we were done discussing about factoring polynomials. So this can be factored out as the sum and difference, right, of two terms. So that's x plus 5, quantity of x plus 5, times the quantity of x minus 5. Again, as I've told you before, you can interchange those. You can have negative first or positive first. Now for the denominator, we can look for the common factor among the two terms. Now common factor there is, it's simply x, right? Extracting the common factor, we divide. That will give us 5 minus x, right? Now if you take a look at the numerator and the denominator, by just simply looking at it, it's not possible that we can cancel right away, but we can transform this one, that certain quantity. So 5 minus x can be transformed as, you can write that one as negative x plus 5, right? Because x is still negative, 5 is still positive. Now extracting or removing the negative sign, or putting the negative sign outside of the quantity, that's negative the quantity of x minus 5. Because if you distribute the negative sign, that will be negative x, that will be positive 5. Now the purpose of this, of transforming the certain quantity, is in order for us to be able to simplify or to cancel certain numbers or quantities from the numerator and the denominator. So we will have x plus 5, quantity of x plus 5, times the quantity of x minus 5, over, this will now be negative x times x minus 5. Now we can cancel. We can cancel that quantity, and we can cancel that quantity. And that would leave us with x plus 5 over x. Now for the negative sign, you can put that in the denominator. You can actually put that also in the numerator. But usually, I put that here in the middle. That will still be correct. That will still be the same answer. Okay? So, one last example. So, suppose we have x to the power of 7 plus 2x to the power of 6 plus x to the power of 5 over x cubed times the quantity of x plus 1 to the power of 8. Now for the numerator, we can extract, or we can look for the common factor among the terms, that is x to the 5th power. After getting the common factor, we can divide, we can simplify. So that will give us x squared plus, that's 2x plus 1 over x cubed times x plus 1, quantity of x plus 1 to the power of 8. Now if you take a look at this certain expression or that certain quantity, that can be further simplified because that is a perfect square trinomial. So the factor of a perfect square trinomial is the square of a binomial. So that's simply x plus 1 squared. Why? Because if you simplify, that is x squared, that's 2x, and that's 1 over x cubed times quantity of x plus 1 to the power of 8. Sorry, this should be 5. Now applying the rule of exponents. If we have the same base but different exponents, and if we divide, we need to subtract the exponents. So 5 minus 3, that will give us x squared. Now here, that's the same base, so different exponents. So 2 minus 8, that will give us negative 6. But if we put negative 6 in the denominator, that will be positive 6. So that's x plus 1 to the power of 6. So that's our final answer. By the way, if you have questions, if you have clarifications, feel free to comment your questions below so that I'll be able to entertain and answer your questions, okay? Next, let's talk about multiplying. So, multiplication and division of rational expressions. Now, basic rule is for multiplication, if we have a over b times c over d. So multiplication of fractions or rational numbers, simply multiply the numerators, that's a, c, and also multiply the denominators, that's b, d. For division, if we have a over b divided by or all over c over d, that can be rewritten as a over b divided by c over d. Now for division, it's different. So what you need to do is copy the dividend, the number that is being divided, or retain that. Look for the reciprocal of the divisor. The divisor is the number that divides the dividend. So reciprocal of c over d is simply d over c. And proceed to multiplication. Okay? So let's have some examples. Suppose we have x squared minus 5x minus 14 over x squared minus 3x plus 2 times x squared minus 4 over x squared minus 14x plus 49. Basically, this is an application of our topic on factoring of polynomial expressions or factoring of polynomials. So before we multiply, we need to simplify first the expressions. Now, here, x squared minus 5x minus 14, that can be factored out. So factors of x squared are x and x. Factors of 14, negative 14, that will result to a sum of negative 5, that's 2 and 7. Now we need to have a negative product and a negative sum. So 2 should be positive, 7 is negative. Why? Negative 2 times, positive 2 times negative 7, that's negative 14. Now, if we multiply the outer and the inner terms, that's negative 7x. Inner, that's 2x. So the sum will give us 5x. For the denominator, still the same process. Factors of x squared are x and x. Factors of 2, that can give us a sum of 3, or 2 and 1. We need 2 to be positive, the sum should be negative. So we can have both numbers to be negative. Why? Negative 2 and negative 1, the product is positive 2. Negative 2x and negative x, the sum is negative 3x. Okay? This one, this expression, that's the sum and difference of two terms. So again, you can have the sum or the difference first. Either way, that's still correct, or that's okay. So that's x minus 2, quantity of x minus 2 times the quantity of x plus 2 over factors of that expression. So that's x and x. Factors of 49, that will give us negative 14. That's obviously 7 and 7. So we need to have positive product, negative sum. So we can have both numbers to be negative. Why? Negative 7 times negative 7, that's positive 49. For the sum, negative 7x plus negative 7x will give us negative 14x. Now, before we proceed to multiplication, we can try to simplify the given expression. So, let's see if we can cancel out x plus 2. No. X minus 7 here. We can cancel that one out. X minus 2. We can also cancel that one out. So, if we're done simplifying, we can proceed to multiplication. So, multiply, that's simply x plus 2 squared, right? And using the FOIL method, that will give us x squared minus 8x plus 7. Actually, you need not simplify the final answer. You can have quantity of x plus 2 times x plus 2 over quantity of x minus 1 times the quantity of x minus 7. But if you can simplify, so this is how it will look like. Okay? Next. So for the second example, let's have m squared minus 9 over m squared plus 5m plus 6 divided by 3 minus m over m plus 2. So, again, rule for division: retain the dividend, look for the reciprocal of the divisor, then proceed to multiplication. But we can actually simplify this one. So, that's sum and difference of two terms, that's m plus 3, it's m minus 3. For the denominator, that's m. Factors of 6, that can give us a sum of 5. So obviously, that's 2 and 3. Both are positive. Why? 2 times 3, that's 6. 2m plus 3m, that's 5m. Now, that's multiplication. Reciprocal, that's m plus 2 over 3 minus m. But this quantity, or this expression, we can simplify, or we can transform into negative m plus 3, right? Because m is still negative, 3 is still positive, we just transformed. that certain expression, we can move the negative sign outside, so that will give us m minus 3, because if we distribute, that's negative m, that's positive 3. Again, the purpose of us transforming is in order for us to simplify later on. Now, before multiplying, let's try to look for expressions or numbers that we can cancel. So, we can cancel m plus 3, we can cancel m minus 3, we can cancel m plus 2 and m plus 2. Therefore, that will leave us with the final answer of negative 1. Okay. So that's for multiplication and division of rational expressions. Now this time, let's have addition and subtraction of rational expressions. As a general rule, so for addition, let's say we have a over c plus b over c. So simply copy the denominator, and all you have to do is add or subtract the the numerator. So the same with a minus c minus b over c. Just copy the denominator. All you have to do is add or subtract the numerator. I'm sorry, that's a minus b. So as a general rule, you can only add or subtract rational expressions as long as they have the same denominator. So for example, if we have 5 over 6 minus 3 over 4. So 5 over 6 and 3 over 4 are dissimilar fractions or dissimilar rational numbers. Why? Their denominators are not the same. One is 6, the other is 4. So in order to add or subtract the certain expressions or the certain fractions, we need to look for the LCD. LCD is the least common denominator. Now, how do we look for the LCD? So during your elementary days, elementary years, you were taught to get the LCD, you need to look for multiples of the denominator. So for 6, multiples are 6, 12, 18, and so on. For 4, multiples are 4, 8, 12, and so on. So since we're looking for the least common denominator, here that is 12. So therefore, LCD is 12. Now, how do we transform 6 to become 12? We need to multiply it by the number 2. So whatever number you multiply the denominator with, you multiply it to your numerator as well. So 5 will now be 10. For the second rational number, we need to multiply 3 to 4 in order to get 12. So if you multiply 3 to your denominator, multiply 3 as well to your numerator. That will give us 9. Now, since the denominator is already the same, all you have to do is subtract your numerators. 10 minus 9, that will give us 1 over 12. Now, that is the final answer, and it's already in the simplified form. Now, let's have this example. If we have 4 over 6x squared minus 1 over 3x to the 5th power plus 5 over 2x cubed. So all their denominators are different. So again, in order for us to simplify, in order for us to add or subtract, we need to look for the LCD. So for the numerical coefficients, LCD there is 6. For the variables, that's obviously x. And for the exponent, we need to look for the highest. So that's 5. Therefore, LCD is 6x to the 5th power. Now we need to transform this one to 6x to the 5th. So we need to multiply by x cubed. Now if we multiply x cubed to your denominator, multiply that as well to your numerator. So that's 4x cubed. For the second term or the second rational number, we need to multiply 2 so that the denominator will become 6x to the 5th power. So if you multiply 2 to your denominator, again multiply 2 to your numerator, that will simply be 2, negative 2. Now here, we need to multiply 3x squared in order for the denominator to become 6x to the 5th. So that will be 5 times 2. That will give us, I'm sorry, did I say 2? We need to multiply the denominator, by 3x squared. So multiplying, that will give us 15x squared. Okay, since for the denominator we need to multiply 3 for the coefficient to become 6, multiply x squared for the variable to become x to the 5th. So this can be your final answer, but we can also arrange the terms in our numerator. So that will be 4x cubed plus 15x squared minus 2 over 6x to the 5th power. Another example. Suppose we have 2 over z plus 1 minus z minus 1 over z plus 2. Now again, we have different denominators, and sometimes the trick in order to get the LCD is we can actually multiply both your denominators. So we can have z plus 1, quantity of z plus 1 times the quantity of z plus 2. So in order to have a denominator like this, we need to multiply by z plus 2. So that will be 2z, it's quantity of 2z plus 4. So you simply need to distribute 2 to z plus 2 minus. Now our goal is to make this look like this. So we need to multiply the denominator by z plus 1. You also multiply that to your numerator. So that will be z squared minus 1, because that's the sum and difference of two terms. Now simplifying, so that is 2z plus 4 minus z squared plus 1. So distributing the negative sign, that will be negative, that will be positive, over quantity of z plus 1 times the quantity of z plus 2. Now we can rearrange, or we can arrange, that is z squared, negative z squared plus 2z, 4 plus 1, that is 5. You can have a numerator or denominator, of z plus 1 times z plus 2, but we can also simplify. So that will be z squared plus 3z plus 2. So that's the difference of the rational expressions. So for our last example, we have 2x over x squared minus 9 minus 1 over x plus 3 minus 2 over x minus 3. So if we take a look at the denominators, it's obvious that our LCD is x squared minus 9. Why? The simplified form or the factored form of x squared minus 9 is simply x plus 3 times x minus 3. So we need not change this one. So simply copy 2x. Now here, we need to multiply the quantity of x minus 3 so that we will have the common denominator. So multiplying, that will give us minus x minus 3. Here, we need to multiply by x plus 3. So minus x plus 3. Now simplifying, that's 2x, distribute the negative sign, 3 will be positive, minus x, 3 will be negative. I'm sorry, there's still 2. So that is negative 2x minus 6 over, okay, x plus 3, x minus 3. Now we can combine like terms. 2x minus x, that is x, minus 2x, that will be negative x. Now for the constants, that's 3 minus 6, that's simply negative 3, over, if we simplify that one, that is x squared minus 9. So that's the difference of the following rational expressions. Again, if you have questions, if you have clarifications, just comment your questions in the comment section below so that I'll be able to entertain and answer your queries. Thank you so much, guys. You take care always. Bye-bye.